Number 1. Velocity. Velocity is defined as the speed of an object in a particular direction. If you don't know the velocity of the ball, you will not be able to receive it properly or even kick it properly. If you know it, you will be able to kick it with accuracy. Knowing the direction that the soccer ball is most likely to go in is very important in soccer. Number 2. Friction. Friction is a resistance force to relative motion of fluid layers, solid surfaces, and material elements. There are 4 different types of friction: static, sliding, rolling, and fluid. The first 3, static, sliding, and rolling friction, occurs between 2 or more solid surfaces. Fluid friction, as the name suggests, occurs in gases and fluids. So basically, when the soccer ball is moving through the air. Number 3. Gravitational force. Gravity is a natural force that acts on all things that have mass or energy. This force has a major impact on how the ball flies. If there was no gravity, the soccer ball would just continue flying in the air and never come back down. The players stay grounded because of the gravitational force that acts on them. Number 4. Momentum. Based on Newton's mechanics, linear momentum refers to the product of velocity and mass of an object. Unlike other forces, it's a vector quantity that has a direction and magnitude momentum that can also be defined as an impetus gained by a moving object. Momentum affects how far the soccer ball goes when kicked. If the player has a lot of momentum when they come into contact with the ball, it will move faster and further away. On the other hand, if there was not enough momentum, the distance that the ball covers will be less irrespective of how hard the ball is kicked. Momentum is calculated by multiplying the velocity and the mass of the ball. How did he do that? Well, first, we have to go back to where it all started off. In 1852, a German physicist called Heinrich Gustav Magnus was trying to figure out why spinning artillery shells sometimes curved in unpredictable trajectories. The ball travelling in this direction means air is flowing across it in the opposite direction, but right near the ball is a thin layer of air dragged around as oncoming streams of air pass the ball. The side moving the same direction as the spinning ball is accelerated and follows the curve of the ball. It's also deflected onto the right. The side that is moving against the ball meets opposing air and can't continue around the ball. It slows down and goes straight. We end up getting a net flow of air to the right, so the ball must go to the left. Since the air is slowing down the right side, we get a buildup of air which creates a higher pressure on that side and pushes the ball to the left. The airflow is extremely important. You cannot make this happen in a vacuum. It's not some weird thing that the ball does by itself. You need air flowing across the ball to push it. This is called the Magnus effect.